Right, so in this question, a water tank is cylindrical with a base radius of 45 centimeters. So we'll draw that in. Water is pumped into this tank at a rate of 1 litre per second. Okay, so a lot of water going in there. What is the height of the water in the tank after 3 minutes? Okay, now it says here 1 litre, doesn't it, per second. So basically 1 litre in 1 second. That's what is going on here. Okay, 1 litre of water is going in every second. Now we want 3 minutes, don't we? Okay, so how much water will be in this tank after 3 minutes? Well, 3 minutes, if you think about it, 3 minutes, well, 1 minute is 60 seconds, yeah? So you know 3 minutes then is 180 seconds. So if it's doing 1 litre in 1 second, you need to times this by 180. So then you've got 180 litres being poured in. Okay. Now we know 1 litre, or we need to know, right, in the exam, this is important, okay, that 1 litre is 1,000 centimetre cubed, right? That's what 1 litre is. It's 1,000 centimetre cubed. It's just something you've got to remember. I'm going to change this 180 litres into centimetre cubed because they are asking for the height of the water, right, after 3 minutes. Okay, so I don't know where it is. The height could be there, right? Could be there after 3 minutes. But in order to do that, right, in order to establish that, of course, I'm working in centimetre units, aren't I? Because it says the radius is 45 centimetres, so I need to change this into centimetre cubed. So if 1 litre is 108, if 1 litre is 1,000 centimetre cubed, 180 litres will equal 180 times 1,000, so that'll be 180,000 centimetre cubed. And what we do now is to get the height of the tank, we just work backwards, okay? So we say, look, the volume of the water is equal to this, 180,000 centimetre cubed, right? And of course the volume of the water forms the shape of a cylinder, so we can use the cylinder formula, pi r squared h equals 180,000. Pi is 3.14, radius 45, squared then equals that. So I work out this on the left hand side. So I get 6358.5 times h equals 180,000. So h then will be 6358.5 underneath the 180,000. So I get 28.3 centimetres. Okay, part B, it says a large container when full holds 24 litres of water measured correct to the nearest litre. Okay, so that's a bit important there, isn't it? We've got boundary values here, but it looks of it. Write down the least possible value and the greatest possible value in litres, the amount of water in the full container. So, a little sort of number line might help. Okay, the fact that it's been measured in litres, right, to the nearest litre means my scale, right, is going up in 1 litres, okay, because when it says nearest litre, that's what the scale is, right, going up in litres. Now, it's been measured to be 24 litres to the nearest litre, so I go directly in between 23 and 24, right, to get the least. So the least then will be 23.5, and the most will be 24.5, okay. Okay, so anything within those values then would round to 24, right, so that's what we put there. It says then a tank has a capacity of 320 litres measured correct to the nearest 10 litres. Explain, showing all your calculations, why it's not always possible to empty 13 of the large containers full of water into the tank without the tank overflowing. Okay, so let's deal with this tank. Okay, the tank, okay, it doesn't matter how you draw your number line, go horizontally as well. The tank is 320 litres measured to the nearest 10 litres. That means my ruler, or my way of measuring, is going up in 10 litres, right? So the scale on this measuring tape, or whatever, how they're measuring this, right? Nearest 10 is going up in tens, and they've said it's closer to 320. We've rounded it to 320, which means the most it could be is there, isn't it? 325. The least it could be is here, 315. Okay, it can't be less than 315 because then we round to 310. Okay, so we'd say, look, the least is 315 litres, greatest is 325 litres. Now, it's saying, look, show the calculation why it's not always possible to empty 13 of these large containers. Well, if it's not always possible to empty 13 of these containers into the tank without it overflowing, what we're better off doing is obviously choosing the greatest container, isn't it? If we choose the greatest and we've got 13 of these, you know, it might overflow. If we choose 13 of the smallest ones, right, the smallest ones, it might not overflow. Okay, it might not overflow, it might fit in there, which is great. Okay, but to show that actually it's not always possible to put these 13 large containers in without overflowing, choose the largest, right? So 13 times the greatest container. So 13 times 24.5, which equals to 318.5. So 13 of these is actually greater than the smallest size tank. Okay, so you could say, look, this is a greater volume than the smallest or the least possible size tank of 315 litres.